Welcome to Awesome Tutor, and today we're going to be looking at the sine rule. Okay, so here we have a triangle. Any triangle, doesn't matter. Okay, any triangle this rule applies to. So let's call that angle A, and the opposite side of that angle will be side A. This is angle B, the opposite side, we'll call that side B. Same thing with C. So this is the rule. Sine of the angle A over the length of its opposite side is equal to sine of the angle B over the length of its opposite side, which is equal to the sine of the angle C over the length of its opposite side. It can also be written like this, and it doesn't matter which one you use, but it's usually better to use one than the other depending on whether you're finding the length of a side or an angle. So it doesn't actually matter if you call this angle B, as long as the opposite side you give it the corresponding letter. So this could be angle A, and that could be side A. This could be angle C, and that could be side C. Whatever. Could be D, could be E. Whatever you call it, doesn't matter. The rule is the sine of an angle in the triangle over its opposite side is equal to the sine of another angle in the triangle over that angle's opposite side. So it doesn't matter what you call them. Let's look at a question. So Star Destroyer B is 600 kilometers on a bearing of 20 degrees from Star Destroyer A. Star Destroyer C is located on a bearing of 55 degrees from Star Destroyer A, and on a bearing of 120 degrees from Star Destroyer B. Work out the distance AC and the distance BC. Try this by yourself, but if you have no clue how to do it, I'm going to do it in a minute, so just wait. So they form a triangle. Now it's said that the distance from A to B is 600 kilometers. And said that it's on a bearing of 20 degrees from A. So draw the north line from A. That will be 20 degrees. And C, it said it's on a bearing of 55 degrees from A. So that whole angle here is 55 degrees, which means this little angle here is 55 minus 20, which is 35 degrees. It also said that C is on a bearing of 120 degrees from B. So draw the north line. That angle there is 120 degrees. Now you've drawn the triangle as given you in the question. Now you have to work out this distance and this distance using the sine rule. Now, there are many different ways to do this, but all require the same little trick. You extend one side of the triangle so you can find the other angles. Okay? I'm going to extend this side. Alright? And now I know that this angle here will be 180 minus 20 degrees because that's a straight line. So this angle will be 165 degrees. Now, because this north line is parallel with this north line, because they're both pointing north, and this is all the same line, that means that this angle here will be the same as this angle here, 165 degrees. Now we can work out this angle inside the triangle, because that essentially makes a circle. So 360 degrees minus 165 minus 120, and that's going to give us 80 degrees inside the triangle. Now we can easily work out this angle, because all angles in a triangle add up to 180. So 180 minus 80 degrees minus 35 degrees, and we're going to get 65 degrees. Now, I know one side, and I know its opposite angle. So that's going to be the base of my calculations. Okay? 600 over the sine of 65 is equal to the side AC over the sine of its opposite angle, which is 80 degrees, which is equal to BC over the sine of its opposite angle, which is 35 degrees. Now, do them separately. So let's do this first. Rearrange it, and you get AC is equal to 600 over the sine of 65 multiplied by the sine of 80. Now let's do this one. Rearrange it, you'll get 600 over the sine of 65 multiplied by the sine of 35, and that's going to give you BC, because this is the denominator, so you just multiply to move it to the other side. Okay, this is just solving equations. And that should give you AC is 652 kilometers to 3 significant figures, and BC is 380 kilometers to 3 significant figures. Let's look at a different question where we try and find the value of the angle, not the side. Okay, so here's a triangle. The missing angles are x degrees and y degrees. Find me those missing angles. Go. Okay, so first let's focus on x. Forget about y, forget about this part of the triangle. Just look at DBC. Okay, we know this angle, we know this side. That's going to be the base of my calculations. So sine of 80 degrees over its opposite side, 8.5. Now here in this part, in this type of question, I'm putting the sine of the angle as the numerator and its opposite side is the denominator. Whereas in the previous question, I did the opposite. For this question, when I'm finding angles, I put the angles on the numerator because it's easier to rearrange. Okay? And you'll see soon. So, we know this side, and that's its opposite angle, which we want to find. So sine of x over 6.2. We rearrange it, we get sine of x is equal to sine of 80 degrees over 8.5 multiplied by 6.2. If sine of x was on the denominator, then you can see that it would be harder to rearrange. Not that difficult, but just put in the numerator, okay? So, that comes out to be this value right here, but are we done? No. This is sine of x. We want the angle x. So what we do is we do inverse sine of whatever came up in our calculator. So 0.7183 blah 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 blah. And that will give us x. So x is 45.9 degrees to 3 significant figures. Now let's find y. Okay, now we find y. Now this is a bit more difficult. Okay, first of all, I'm going to find this angle, because it's really easy to find, because we know this angle, we know this angle. So 180 minus 80 degrees minus 45.9 degrees gives you 54 point something degrees, okay? Because this is not 45.9 degrees, it's 45.9 something, okay? When you're in an exam and you have values in your calculations which have lots of decimal places, do not round them till the final answer, because then your calculations will not be exact and your answer might be off by a couple of decimal places, okay? For this video, I'm not going to give the full decimal places, okay? I'm not going to give the full value, but in your exam, you should either write out the full value or keep it in your calculator, okay? So 54 point something. Now, I can also find this angle, because this is a straight line, so 180 degrees minus 45.9 degrees gives us 134 point something degrees. Okay? If we find this angle, let's call it theta, we can easily find y. Now what I'm going to do is, we have this triangle separate from this triangle, right? Why don't we look at this triangle as a whole? So that's B, that's C, and that's A. That'll be 54 point something degrees. and that will be 80 plus y degrees, and that will be theta. We know that that is 7.5 centimeters. We know that that's 6.2 centimeters. We have a side, we have its opposite angle. We can work out theta using the sine rule. So sine of theta over its opposite side 6.2 is equal to sine of 54 point blah 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 over its opposite side 7.5. You rearrange, you'll get sine theta is equal to sine 54 over 7.5 multiplied by 6.2, and then you obviously inverse sine that, and then you get theta is equal to 42.027 blah 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 degrees. So now we have that angle. We can easily find y. 180 degrees minus 134 point blah 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 minus 42 point blah 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 gives you y degrees. Okay, so if you kept these these values as they were in your calculator, then you should get y is equal to 3.89 degrees to 3 significant figures. This is where you round, because it's your final answer. Okay? Alright, now I'm going to show you the special case. Okay? And you'll see what's so special about it. It gives you the length AB. It gives you the length AC. It gives you the angle B. It wants you to find the angle ACB. Okay? So we use the sine rule. We know this angle. We know its opposite length. So that's going to be the base of our calculations. We're finding an angle, not a length, so we keep the angles in the numerator and the length in the denominator. So sine 44 over 3 centimeters is equal to sine of angle C over its opposite side, which is 4 centimeters. So sine C is going to be equal to sine of 44 over 3 multiplied by 4. If you work that out, you get C is equal to 67.9 degrees to 3 significant figures. Okay? Hold on, that can't be right, because here it's clearly an obtuse angle, which means it's bigger than 90 degrees. But this is an acute angle, which is smaller than 90 degrees. So you must have done something wrong. Well, this is where the special case comes in. Because you're using inverse sine, okay, the sine graph looks like this. For one value, there's more than one x value. So inverse sine of whatever you have here can give you more than one answer. If you continue the sine graph, it can give you even more. Okay? This is what you found. You found the acute angle, 67.9. The other possible values for that angle are this one. Forget about these because you're never going to get an angle that's bigger than 360 degrees. Okay? So these are the two main ones. Yeah? This is the obtuse angle, which is this angle right here. To find that angle, you do 180 minus your acute angle. Okay? Obviously with all its decimal points, don't round it yet. And you get 112 degrees to 3 significant figures. Okay? So that's the answer, 112. So when you're in an exam and you get the answer, 67.9, and you don't check the diagram, you don't see what they gave you, and you don't see that this can't be right, you're not going to get the mark. Okay? You need to look at the diagram, look at your answer. You need to be wary of the special case. Okay? Because it could either be obtuse or it could be acute, depending on the diagram. Why is this? Okay? Because this could also be the line AC, where it's 3 centimeters. In which case, that will be your triangle, and you'll get the acute angle, 67.9 degrees. Okay? So always be careful with this special case. This has been the Awesome Tutor. Bye.